All right, so I was screaming on the last one because I wasn't paying attention, and I hit min instead of sum. And so I just want to clarify that real quick. So hit second stat, scroll to math, hit option 5, hit second stat, scroll to ops, hit option 5. And then I already have everything in there from when I screwed up. And so now hit enter, and we've got 9.4. That's a much better approximation. So again, I screwed that up right there. So I wanted to clarify that. All right. So last problem on this one. And it's the same process, but this one is trig. And for some reason, people don't like trig. Trig is a blast. I don't know why. But what we're going to do is I'm going to go ahead and set these things up for you so you can work through it. So it says use the rectangle. So on this one, I've got 1, 2, 3 rectangles. On this one, I've got 1, 2, 3, 4, 5 rectangles. So again, how can we better approximate? The more rectangles you can get, the better approximation you're going to have. Now I need you to think about this for a second. If you'll notice, with 3 rectangles, they're kind of wide. With 5 rectangles, they're getting narrower. So if you have an infinite number of rectangles from here to here, how wide will each one be? And it will essentially be a width of 0. So you're looking at just a whole bunch of lines that are right smack next to each other. And then, but we're going to approach them as using rectangles instead, where that width is approaching 0. And that's where calculus comes in. Because of course you can't have a rectangle of width 0. Anyway, here we go. All right, so on this one, pay attention to which side of rectangle 1 attaches to the curve. So here's rectangle 1, but here's my curve, and it's the sine curve. Okay, oop, that was lovely. Okay, and the right side of the rectangle is what we're going to be using this time. Okay, so how do I do this? Because I'm just going to go ahead and start going in. So I have the sum of the sequence of. All right, so how do I figure out the area of each rectangle? Well, the width of each one of these on the first one, well, if this is 0, this is a half of a pi, and this is a full pi, okay, then this must be pi over 4. It's a fourth of a pi. So this is pi over 4, pi over 2, 3 pi's over 4, and 1. Okay, so how wide is each rectangle? It is pi over 4 wide. How tall is each rectangle? And remember, your height is going to be determined by your function. So my function is sine. Okay, so I have sine x. And then comma, or go to the next part. Okay, what's your variable? My variable is x. Okay, where do I start? Be very careful. I need to start on the right side of rectangle 1. So what value is that? I need to start at pi over 4. Where am I going to end? I need to end at the right side of rectangle 3. So what is that? That is 3 pi over 4. 3 pi over 4. And then what's your increment? Your increment's going to be the same as the width. So my increment is pi over 4. Okay? And then close that out. You'll have that one done. Now, let's do this one because it has some more. Okay, it's still sine, but this is a pi. This is 0 pi over 2 and 1 pi. So this is a half of a pi. Well, I need to divide it into units of 6. So this is 1 pi over 6. This is 2 pi's over 6, which is pi over 3. This is 3 pi's over 6, which reduces to pi over 2. This is 4 pi's over 6, which reduces to 2 pi over 3. This is 5 pi's over 6, and that's 6 pi's over 6. All right, so for this one, we're just going to do the sum of the sequence, and then you'll notice a lot of it's the same. Where are we starting? We're going to start on the right side of rectangle 1. So the right side of rectangle 1 means you're starting at pi over 6. Okay, so I start. Oh, heavens to Betsy, I'm screwing you up. All right, this is pi over 6 because that's the width of each one. Sorry, I got all excited. And that's sine x. All right, so there's your width. Each width is pi over 6. Your height is the sine. What's your variable? It's x. Where are you starting? You're starting at pi over 6. Okay. Where are you ending? You're ending on the right side of the 5th rectangle. So the right side of rectangle 5 is going to be 5 pi over 6. And then what's your increment? How do you move? Your increment will be the same as your width. So pi over 6. So when I do this, please make sure you're in radians. So hit mode and scroll down and make sure you're in radians, which I am. I can't tell if you can see that or not. All right, so I'm in radians. So what am I going to do? I'm going to do second stat math 5. Second stat ops 5. And then I'm just going to clear this stuff out and go. So I've got a width of pi over 4. Okay. And a height of the sine of x. Okay. What is my variable? My variable is x. Where am I going to start? I'm going to start at pi over 4. Where am I going to end? I'm going to end at 3 pi over 4. And what's my step, or what's my increment? It is a single pi over 4. Paste that, and there you go. Okay. Now, another trick, in case you're not familiar with calculators. You can scoot this thing up, if you have the new software, and hit enter, and it will repeat everything but make it editable. And so if I want to go ahead and do the second one, well, what is my width? My width is pi over 6, so instead of re-entering everything, I just need to modify. So this is my function. This is base times height. My variable is x. Where am I starting? I'm starting at pi over 6. Where am I ending? At 5 pi over 6. And then I'm in increments of pi over 6. And then do that. Okay, if you have the old software, you can hit second enter, and it'll do the same thing. The new software just allows you to use the arrow keys. So that's it. You have successfully done section 1.1. If you're feeling overwhelmed, please don't. There's a ton of information in section 1. So we kind of overwhelm you a little bit. For the most part, I'm going to try and get it done in 2 or maybe 3 videos for the rest of the course. But please let me know if you have questions. Do not ever hesitate to reach out.